Hi, everybody. Josh Byerly here inside Mission Control Houston. I'm joined by my friend Cady Coleman, again, former, well, not former, the current astronaut, former space station crew member. Cady was really instrumental in the HTV that happened last year. It was HTV 2, right? It was the second one that flew up there. So, she's really an expert on how these things go up there on board the station. We've been talking a lot about how the crew's getting ready to greet this thing tomorrow. So we figured Cady would come in here and actually tell us here on Earth, what it's like for the crew to work on these things. So Cady, talk a little bit about, it's the day before this thing gets up there. The crew's going through quite a bit of onboard training, kind of making sure that they've got all their procedures ready to go. What was it like whenever you were up there doing this?
Well, this thing is big.
Yeah. Yeah.
And basically, it launches in a rocket and, comes up to meet the space station. And then, this and the space station are flying in parallel.
Yeah.
And they're both going 17,500 miles an hour together. And so then the crew, which was myself and Paolo Nespoli last year, are at the controls of the robotic arm. And controlling that robotic arm, now I'm going to be the arm, they're going to go for this. I don't know if you can see this grapple pin right here. It's a little pin. That thing is actually as big as my arm here.
It's huge.
So it's really, really, this whole thing is really big, like the size of a school bus. And so they're going to reach out with the robotic arm and grab this thing. And the trick is, it would be easy if something happened, if the space station could just move away. But the space station is very big and hard to maneuver. And so we have to have it really just perfect, because if something goes wrong and we, bang this thing and then it's going towards the space station, we could all be in big trouble. And so we do a lot of training, to model what, as this thing is flying along, it's actually keeping itself in a nice little box. And, just making sure that it stays in one place. But before we grab it, we want to make sure that it is not trying to go anywhere. So we send a command called free drift, meaning these little jets that help it control where it goes. We tell them they can't fire. But if it's on its way to, going maybe this direction, as it was kind of just doing its little circle here, then it's going to be continuing. So with the robotic arm, we have to track that. We have to be, following the pin. And so we actually practice, what's much more exciting than the actual day. We practice as if this thing is, running away and we are trying to catch it and trying to make good decisions about what if things happen when, that are unexpected.
Right.
On the real day, the first one and the second one of this vehicle have behaved perfectly. And there it was with just a tiny little drift, and we could reach out with the robotic arm, grab this thing, and then we're actually going to, anchor this end onto the space station.
Right.
And then we'll open hatches and go inside, and we've got all the supplies that have been planned for experiments, care packages, probably for us. A lot of different kinds of supplies. But it's one of the most critical things that this crew will do. So it'll be a high point of their expedition.
So let's talk about, we were talking about before we came on the air that you guys trained for 2.5 years. I mean, it's a long training program to get ready to fly up to station. How much do you train just for general robotics, just kind of anything that could come up there versus something that's specific like HTV, or like we talked about before with SpaceX's Dragon? I mean, what's the difference between kind of overall training and really training for this real task that you're going to have to do?
Well, all of us train in robotics, just the general principles of, if I'm going to go and grab this with the arm, right now you and I have this view right here, and we can tell how close I am, closer, closer, closer. But if we only have this view, we don't know how close we are. So we're training all the time the principles of, do you really know what you're doing? Do you really know where the arm is going? And what are you going to do when it goes someplace different? So we're always training those general things. But with a situation that can be as dynamic as this one, you need to be just physically and mentally proficient. So that means practicing a lot, the few weeks ahead of time. And that means in the few years before that, making sure that you really understand what you're doing and that you have good hand controller skills. We're not only going this way, but we can move the hand controller and move the arm this way, but it also can move in pitch and yaw, and all those things are kind of interconnected. And we have to practice really looking at a picture, a two-dimensional picture, and understanding in 3 dimensions what this vehicle
what you need to do
might be doing. So there's a lot of different practice, but some of that 2.5 years is generic space station systems. I mean, I would say one of the frustrating parts of an astronaut job is just that we train a lot for things that are hopefully never going to happen. What if this thing breaks on the space station and we can't get hold of mission control and they can't help us solve the problem?
Sort of worst case scenarios.
Exactly. So we train for a lot of those. It's necessary. It's part of the job. And when things almost happen, it reminds you that you need that training.
Yeah.
I mean, we had some of those things on board.
Yeah.
You know, in the middle of the night, an alarm rings,
Yeah.
and you know, you race down to the computer, all of you, and figure out what it is. And one time we were actually pretty excited because we thought we might actually get to go do a spacewalk, but it turns out that, you know, NASA being NASA, we already had a spare of that box already outside, and
Always
all we
prepared.
had to do was you know, change the power and the data path, and everything
Yeah.
was all set, and we did not get that spacewalk.
So you know, this is a pretty cool looking cargo craft. I mean, it takes up supplies, but it's really, I mean, it's a cool looking thing. I mean, just looking at the model is pretty neat. So talk about whenever you saw it in person, and also whenever you saw it in space.
Well, it's amazingly complicated. I mean, let me just tell you something that's not obvious is that there's a whole bunch of cargo. We're going to go in this end. We're going to
Hmm.
attach this end of the space station, and this end is filled with cargo. Okay.
The pressurized part. Yeah.
But then there's this, and I can't take it out of this model, but it's like a little cart, like a
Hmm.
little wagon. So and there's another grapple fixture, one of those things
Yeah.
that the robotic arm can grab onto. So along with the ground, who's going to do a lot of these operations this time, the ground is going to actually use the robotic arm to grab that grapple fixture, bring that cart out. We're going to hand this cart, which is carrying a bunch of really important spare parts for the space station, we're going to hand that to the Japanese robotic arm. And so the Japanese, and so here, if you hold that for a
Okay.
second, you know, it's almost as if you've got that, you're the space station robotic
Hmm.
arm, and now I'm going to then grab it with this robotic arm, then you let go, and then I have it. So
It's
we
like
do
a
a
handoff.
handoff
Yeah.
between two robotic arms on the space station.
That's pretty
And
cool.
Aki Hoshide will be flying the GEM robotic arm. Joe Akaba and Sunny Williams will be flying the space station robotic arm. And so this cart, this you know, platform that's got the spares on it, will be sitting on the back of the Japanese module, and then that Japanese arm they'll park it there.
Hmm.
We'll reach down, pick up some of these spare parts, and put them in their places on the space station. So there's a lot to this vehicle that you know, it looks like just one big craft, but it's got a lot of different functions.
Talk about the cupola. You know, whenever you're up there, we see these views all the time, and it's really kind of revolutionary that the crew gets to see that much, you know, that much around. I mean, whenever you see these vehicles fly up there, you know, we talked about you don't really get a sense of the size of it, and then all of a sudden you're looking out these windows, and I mean, it's a really big spacecraft. What is it like to actually see that in space? Does it get your attention?
Well, you know, I told Aki today, we were telling him when and where he could see the HTV because
Hmm.
you know, today it's getting closer and
Yeah.
closer and closer. And I said, remember, Aki, objects in the mirror may be larger than they appear. But actually, it looks really big. I mean, at first, when you look down, the first time you see it, it's pretty exciting because you see
Yeah.
this tiny little thing, big Earth, tiny little HTV, and you think, okay,
Yeah.
that's okay. And then it gets closer and closer and closer, and it is the size of a school bus.
Hmm.
It is giant, and it is only about, I don't know, 15 feet away from the space station
Yeah.
when you actually grapple it. So it's big, and it's amazing. And because there's no atmosphere out there, everything is very sharp and very clear. I think it makes it seem that much bigger
Very high
and that
definition.
much
Yeah.
closer. So I tried not to think about that when Paolo and I was on the controls of the robotic arm, and Paolo was telling me, you know, how close I was getting as I was grappling. So
Yeah.
I tried not to think about that part and just, you know, do it like we practiced. But it was really beautiful to see the HTV overland over Japan.
Hmm.
We actually did the capture over New England, where I'm from.
Oh yeah.
So it's just pretty neat to, you know, just see this supply ship actually have a life all over the world.
Yeah. What is it like to actually go inside of it? I mean, I know you're looking forward to the care packages and things like that, but whenever you open up the hatch, is it different from the other vehicles? Does it look different on the inside?
It's like a big closet,
Hmm.
okay, where it's got, you know, it's a big square closet, and it's almost like you have four doors,
Yeah.
and in back of each of those doors is a lot of stuff. But then strapped to the front of each of those doors is also a lot of stuff. So in order to get to things, you actually have to start in the middle, which when it gets there, it's pretty packed, so
Hmm.
there's not much space there. So you have to unstrap the stuff from the outside, find a place to put it on the space station, which fortunately the people here on the ground have thought about all that.
Yeah.
And they've got a plan for almost this shell game of, you know, this gets here and this goes here and this gets
Yeah.
put away there. But one thing that was surprising, I think, to us was that it was confusing to go in there.
Really?
Because, you know, we're used to coming to, you know, an intersection. We're in the space station. We're going down the hallway. We can go left and go into the gym. We can
Hmm.
go right and go into Columbus. And then the hallway ends right there. That's where the space shuttle would dock
Yeah.
usually. But now suddenly there's something down there.
Yeah.
And so we usually go in kind of head first. And then somehow when you come out, you're always facing a different way than you really expected.
You have to get your bearings.
And we find that at these intersections where there's something coming in this way, this way, this way, and then one more way where it's not just sort of the horizontal axis of, a left and a right and a straight ahead. As soon as you put an up or a down in there, when you come out of there, you have to almost look around. In fact, we label the sides because it looks round here, but the hatch itself is square,
Yeah.
and so we will label them port, starboard, aft,
Yeah.
so that we know where we're going and we don't suddenly start flying, in the wrong direction.
We even saw that during shuttle missions whenever you had the multi-purpose logistics modules being attached. I mean, you're really adding a new
Exactly.
room. I mean, it's like if you added something onto your house all of a sudden just in a day, it kind of changes the layout a little bit. So
It's big,
yeah.
and it was kind of fun. We have conferences with our families once a week, and we have computers that have video cameras on them. So it's almost like we get to have a video conference, but these computers are wireless. So I got to actually take my family,
Fly through.
into the HTV. I said, okay, so here we go. Okay, hold on, and we went down into the HTV and we looked around. It's just really pretty neat to be able to take them in there and
It's
have
like a
that
cool
become
field trip. Yeah.
three-dimensional
Yeah.
to them as well.
Well, it looks so clean. I mean, it's just whenever we see these videos of these new modules and these cargo craft, everything's so pristine and organized, and I mean,
Right.
it's awesome to see
Though
it.
even though we know that, something that we do as a matter of safety is we think that everything will be clean, but it was packed on the ground.
Yeah.
Everything had gravity to sort of sit it, and plus it had a pretty big shaking probably on the way up in that rocket. Things might have come loose, and now they'd all be floating. So usually when we first go into a module, we'll actually wear goggles.
Yeah.
And maybe a mask, just in case there's little small pieces of dust or metal,
Yeah.
could really harm your eyes. And so we're usually, we're careful the first time we go in until we establish that actually it really is clean inside.
So talk about the reverse process, how you basically unbirth it, and is it exactly the same, just backwards? Is it easier? Is it harder? What?
Um, I would say, it's certainly easier to release. In that, so here it is attached to the space station. We're going to grapple it by that grapple fixture with the robotic arm. And that robotic arm doesn't look very big, but really the end of it that's going to go on here, that thing is this big. It's huge, right? So we're going to go in there, we're going to grab this, make sure we have a good hold, everything's locked down, and then we're going to release all the bolts that are holding it to the space station, and then just do this sort of big giant swing around into the correct position to then let it go, hopefully without giving it a push.
A push.
Because, we don't really want to give it a push.
No.
We want to have it floating in exactly the right attitude, and then it's got its own way to push, which is these little jets, where there's gases that combine to go psst, psst, and they can then move the HTV in a safe trajectory away from the space station. And of course, there's folks that spend a lot of time doing math, which is why we're trying to always, convince our kids and their friends to study math and science and engineering, is that everything we just talked about today has to do with math and engineering. Somebody had to figure these things out, and the reason that somebody like me is safe up there is because of math.
Yeah. There's a lot that goes into planning. I mean, we you talked about it a while ago that it looks so kind of slow and easy while it's up there, but both those spacecraft are going incredibly fast. They both weigh a lot.
I don't even
pounds.
remember how many tons.
That you're
12
quizzing a
tons?
public affairs person. Let's see, the
6
station's
tons
a
of
million.
cargo?
Yeah, 6 tons of cargo. It's
Something like that.
Yeah,
I mean,
it's a big,
really heavy
spacecraft.
Yep. And that's the thing with things that are weightless, is even something this big and this heavy, given a push, has now got its own momentum. And it will continue going in that direction until it's got a force that opposes it. So you really want to learn how to be gentle, and also, we practice a lot in a simulator. And I'll tell you, that was something that was kind of surprising to us up there, is that I practice a lot in front of something that looks like a video game. And I've practiced, this part of it, and looking at a cartoon picture of this and all those things, and the reality of being in the cupola, where windows surround you, both here and up above, is very disconcerting.
Is it?
To just have that, all that, you know, that stuff in the way. And in fact, it was actually hard for us to remember. I've talked about the judging of the distance.
Yeah.
So this was Paolo's job, was to understand how to judge the distance. Now, meanwhile, we're going over the Earth at a couple miles a second, right? And so the Earth is moving, And it was hard to judge this distance, harder than in the simulator. So we've now prepared other crews to know that, looking at this thing is going to be a little bit difficult, judging the distance, because it's like when you're sitting in your car and the car next to you moves,
Yeah.
and you wonder which one is moving.
Which one's actually moving?
Right. So that made it a little bit difficult. But just that view out the window is just astounding. And
Well, it's going to be. I mean,
beautiful.
I don't think anything can prepare you for that. I mean, you can see any kind of high definition imagery that we can ever invent here at NASA, and it's probably not what you actually see with your own eyes while you're up there, I would imagine.
It's beautiful, and the cupola is a big change for us in that all the windows on the space station up till then were portals. So they're just single circles like on a boat, and you see the world go by very quickly. And so if you're looking, like for example for Hawaii, you can see on our computer program that Hawaii is coming.
Yeah.
And you know actually almost exactly when you'll see it. But you're looking, and boy, you better take that picture right away. But with a cupola, where there's windows now all around, and then also above our head, I can look out and I can see Hawaii coming. And it's getting bigger and bigger and bigger, and now it's over my head, and I'm here. I can turn around, I can see it go. And I have a couple minutes, really, to see Hawaii, and even just to see it in the context of taking magnified pictures where you really see what's going on in Hawaii, or just its place on the whole Earth.
Yeah.
And I love to take those sort of contextual pictures where you see the curve of the Earth and you realize that this is what your country looks like.
Yeah. Well, it's got to be. I can't imagine what it's like to be up there, but you got to get a sense of how fast you're actually going to. Whenever you see Hawaii coming at you, and all of a sudden you're on top of it and you're gone in a matter of just a few seconds. The same thing with these vehicles. They look so tiny, and all of a sudden they're up very close
right
to your
station
station in your face.
Right. And so getting back to what the crew is going to do tomorrow, so it is Sunny and Aki and Joe. This is their big task tomorrow. And Aki and Joe are going to be the pair on the robotic arm.
Right.
We always do these things in twos. They back each other up. Joe will actually be at the controls. Aki will be calling distances for the grapple. And then they'll switch when they're actually going to install this on the space station. And then Aki will be at the controls, and Joe will be calling distances and checking and making sure everything looks right. And meanwhile, Sunny is their third set of eyes, because Joe and Aki are thinking about the robotic arm and how it's doing, and with relationship to capturing this HTV, which has a name actually, Kunitori.
White stork.
Exactly.
Yeah.
It's Kunitori 3.
Yeah.
So they're looking at Kunitori. Well, Sunny is actually in charge of understanding, what if Kunitori has a problem? What if suddenly, the computer says, I don't know all the things I'm supposed to know, this isn't safe. And in that case, that means that Aki and Joe have to back the arm away and then send a command to Kunitori to retreat, to bring itself a safe distance away, which is either about 30 meters, about 100 feet, or even further, depending on what the problem is.
It's very similar to SpaceX, wasn't it? They had the same ability to basically send a command saying, okay, back off.
Exactly. And in fact, we're trying to make all of these supply vehicles that come have similar procedures, so that there's not something special you have to do for one, because all of us can get confused. The crew can get confused. Mission control can get confused. You want to make sure that the procedures are pretty much the same for all of them, and it makes sense actually, because it's all about physics of when it approaches and how to grab it. What might be different is, for example, HTV is much bigger than SpaceX, than the Dragon, and so it's very much heavier, and it has a slower kind of dance that it does when it's keeping itself in one place, whereas Dragon had kind of larger jets but smaller spurts, and so
it was pretty quick.
It could move quickly. It's still not going to go very far. It still has a box, a little place that it has to stay, and the crew knows it will. But it's a question of when they say free drift, Dragon might be darting. It might have been going a little faster and be a little faster to track, but we practice that.
Yeah. Well, Cady, thanks for coming up here. It's always good to talk to you about this stuff. You know this stuff better than any of us could possibly hear on this console.
Well, it brings me back just to be here in Mission Control. Look at I'll be Capcomming for them tomorrow, so I'll be their coach on the ground, so to speak, and representing all the folks here in Mission Control. But it certainly brings me back. It was pretty special days that we had, and it was certainly a highlight of the mission to capture Kunitori 2 and bring her on board the space station.
You'll have to hang on to that model a little bit.
Yeah, I think I'll have to. to give it back. It's a pretty precious model.
We'll be on the air tomorrow morning at 6 a.m. Central Time. Of course, we'll have live coverage of HTV3, and the arrival is Joe Acaba and Aki Hoshide with Sonny Williams helping reach out and grab onto this cargo vehicle and get it installed to the space station. So again, 6 a.m. Central Time, 7 a.m. Eastern Time here on NASA Television. Thanks a lot, Katie.
Sure.
All right.